So I have my demand potentiometer, and as I rotate it, it's going to rotate the demand of the motor. The motor is going to rotate to one of three positions. Now what I can see as I rotate this demand is that my demand in this case is going to be quantized. It's only going to be one of these input values. Now in the assignment I asked for actual angles, so you might have to think about how do these values relate to angles, but I'm just going to use the absolute bit values. So it's 770, 600, 400 or 200. Okay, and then the motor actual position is on the right hand side. So if I ask for 770, on the right it should be fairly close to 770. You can see it's 736, it's not exactly there. If I move it to 600, it should be bang on 600, but it's actually settled at 580. So there's an error there. If it's 400 demand, then it settles at 419. So there's an error there. Now I could just move it manually and reduce that error, but really we want the system to do that by itself. Now there are several ways of graphing. I could graph that using Excel, or I can use a serial plotter. We do like to have the X and Y values calibrated on your graphs, however, but just for the sake of showing you here, the blue is the demand, and the red is the actual value. And you can see that as it moves, there's something there, and we call that, this bit here, we call it overshoot. So it's overshot because of the mass here. There are ways of mitigating that. And what you can see is also an error. So the difference between the green and the blue are the error values. Remember when I said I want demand it to be at 700, but it's actually at 584? Well, that's what we can see as an error there. So as I move it between each step, this is why we wanted you to do steps, because you can see the errors quite clearly. And so what I'd like you to do is also think about how can you minimize those errors. So as we see this moving, we can see it graphing, but obviously you can't include a video with your assignment, but what you can include is a graph. So the graph really tells all of the stories about how well you've controlled this system, and if you can have a look at where it could be improved, and maybe you've had a go at even improving it as well. There are ways that you could improve that. For example, removing this difference, removing this overshoot here will be the two low-hanging fruit ones to go for.